In this video, we're going to graph linear equations by using slope. First, we need to talk about what the slope-intercept form of a line is. We see the formula as y equals mx plus b, where m represents the slope of the line. Just m is the slope. M will be a number. X is a variable, so do not include x when you are writing down what the slope of the line is. B represents the y-intercept of the line, and that ordered pair would be 0, b. So we typically would write the ordered pair to represent the y-intercept. So the first step we need to follow is to plot the y-intercept. Next, from that y-intercept point, we're going to rise and run according to what the slope tells us. If the slope is positive, the rise goes up and the run goes to the right. If the slope is negative, the rise will go down and the run will continue to the right. Let's see how that works in a few examples. For example 1, we're going to identify the slope and the y-intercept first of all. So given y equals 2/3 x minus 4, m is the slope. So that would be just the fraction 2/3. It's positive 2/3. The y-intercept is -4, and we want to write that as the ordered pair 0, -4. So in order to graph the line that has a slope of 2/3 and a y-intercept of 0, -4, we start by plotting the y-intercept, 0, -4. From that point, we would rise and run according to what the slope says. The slope says 2/3, so we have a rise of 2, which is a positive number, so we're going up 2 units. 3 is the run, and that will go to the right. So we start at our y-intercept, go up 2 units, and to the right 3 units. Place another dot. We can keep rising 2 units and running 3 units, and now we're ready to draw the line. Our line, remember, has arrows on either end to show that it continues in both directions. So this is how we can use the slope and the y-intercept to graph a linear equation. In our second example, you can see that the slope is a negative number, and I'm placing the negative with 3. Because we need to choose either the numerator or the denominator to place that negative sign. It doesn't matter which one you choose. So I'll start with -3/5. Positive 2 is the y-intercept, so the ordered pair would be 0, 2. I'll start by plotting 0, 2. And from that ordered pair, I'll rise and run according to our slope. So the way I've written it, rise is negative. So I go down 3 units, and then run is +5, so I go to the right 5 units. So going down 3 and over 5, I would have another ordered pair. But I want to show you that it's also okay to have a slope that's 3/-5 if you want to find another ordered pair on this line. This time the rise is positive, so I would go up, and the run is negative, so we go left. So a rise of 3, left 5. And you can see that all of those dots do line up in a straight line. It's just one more way to consider that slope. But standard form tells us to put the negative with the numerator. When we write it, it always should be in the numerator. But if you're looking for another point, it's okay to place the negative in the denominator to generate another point. So you're rising 3 and running 5. In our last example today, we have y equals negative 5x. Notice we don't have the plus b, so you could consider that as plus 0. The slope is negative 5. It goes through the origin 0, 0. So I'll plot 0, 0. Now you might be thinking, well, with negative 5, I don't see a rise and a run. So think back to how could we change an integer into a fraction? So anytime we divide by 1, we're not changing the value of a number, but it is a nice way to now have a rise over run. So from the origin, we're going to go down 5 units and then to the right 1. Remember, the other situation could be to place the negative in the denominator only and not the numerator. So from the origin, I could have risen 5 units up and 1 unit to the left, and now I'm going to have 3 ordered pairs in a row to plot this line. So don't forget to use the arrows on both ends of your line.